The last type of limit that we'll be talking about today are limits at infinity. And these we deal with many times with just rational functions where you have f divided by g and where f and g are both polynomials. And this goes back to what you learned in Algebra 2, Algebra 2 honors, pre-calc honors. Basically what you want to do is look at the ratio of, well, you want to look at the highest degree exponent in f versus the highest degree exponent in g. And we're going to go with the fact that of the function 1 over x, and I drew this on another page, but the basic graph of 1 over x, as x goes to infinity, do you see how there's an asymptote here, and the y value goes to 0? That works the same for x going to negative infinity. So we use that as our basis. We take a look at the first one here, and we have a larger degree in the denominator, because in the numerator, our degree is 1, and in the denominator it's 2. So your limit at infinity is going to be equal to 0. This isn't equals because these are hard and fast rules. The next one has a degree of 4 in the numerator, a degree of 3 in the denominator. Because there is a higher degree in the numerator, our limit will either be quote unquote equal to positive or negative infinity. In this case, because we have 4 over 37, and we're going to where x equals infinity, that means our end behavior will look like this with a slant asymptote. So that means that this limit is technically infinity. But this is where we can have a nice discussion about whether infinity is even a limit, because infinity is really a concept, and infinity, by definition, has no limit. It is a limitless value. So what Mr. Walker and I like to say for these types of questions is the limit does not exist, because it is our belief that infinity is not a limit. The good news is the AP College Board will never give you a choice between these two answers. They will never ask you, is the limit infinity or is the limit does not exist? They will give you one or the other, and it is totally okay to use either one. We caution you though, because what if, let me change colors to show you a big what if. What if this 4 out in front here had actually been a negative 4? Then I would have had a negative 4 over 37. My end behavior would have looked like this, and the actual limit would have been negative infinity. And if you had said infinity and the actual limit was negative infinity, you would have gotten it wrong. However, if you had said does not exist, you would have gotten the correct answer, whether the answer is technically infinity or negative infinity. So what Mr. Walker and I like to impress upon you is that you want to just give does not exist anytime you have a larger degree in the numerator versus the degree in the denominator. The last type of problem is when you have the same degree in the numerator and denominator. So 3 and 3, then you just look at the ratio of the leading coefficients. So the leading coefficient here is a 1. The leading coefficient here is negative 2. So this limit at infinity is negative 1/2. So basically, if the degree of f is less than the degree of g, then the limit is equal to 0. So that's a smaller degree in the numerator, larger degree in the denominator. If the degrees are the same in the numerator and the denominator, the limit is the ratio of leading coefficients. And then if the degree is larger in the numerator, then the limit does not exist.